it's time to talk about the stars. But what a star is? In our universe, stars are gigantic spheres of plasma and gas that use matter as well to essentially burn in space for billions of years. Star gives energy to their surroundings, and in our planet, our star, the sun, is essential to all life that inhabits the Earth. But how are these objects created?
First, let's talk about nebulas. A nebula is a massive cloud of dust and gas in space, mainly hydrogen and helium. These clouds sometimes are a product of the gas and dust thrown out by an explosion of a dying star, known as a supernova. Other nebulas are regions where the stars begin to form. For this reason, they are known as a star nurseries. Dust and gas are very scattered, but as we know, gravity makes objects with energy or mass to attract each other, so the dust and gas slowly gathers together. Eventually, matter starts to clump in groups bigger and bigger, making its gravitational pull stronger. When we talk about gases, we can remember that the molecules that make up the gas have kinetic energy. In this context, this means that the gas exerts pressure as an outward force, and it is effectively in the opposite direction of the gravity's pull. So there is an equilibrium of forces that make a cloud stable that we call hydrostatic equilibrium. For the next step, an instability has to occur, otherwise the nebula will get enough temperature to become a brown dwarf. And to create a star, the instability comes when the mass reaches a critical point called gen mass. This is given by the following formula, where m is the mass per particle, T is the temperature of the clump, K is the Boltzmann constant, ρ is the density of the clump, assuming it remains constant, and finally G is the gravitational constant.
Upon reaching the critical point, that is, Jean's mass, the clump starts to collapse as the kinetic energy of the gas can no longer support its weight and the gravitational pull overcomes it. If the nebula doesn't get to Jean's mass, it instead will increase its temperature enough and a brown dwarf will be created. The first clump that falls of the nebula upon reaching Jean's mass are called protostars. They have their own gravity and identity. As a protostar forms, gas falls into its center, releasing kinetic energy in the form of heat, and temperature and pressure of the protostar begin to rise. It becomes then a source of infrared radiation. Throughout the first collapse, the clump remains transparent to radiation and the collapse proceeds rapidly, but it becomes more and more dense. As stated earlier, the radiation emitted is suddenly trapped, and the temperature and pressure of the center increases. The pressure eventually stops the gas from falling to the center and it becomes a stable protostar. With enough temperature and pressure in the center of the protostar, nuclear fusion begins to occur in the core and the star is born. In the nuclear fusion process, the nuclei, particles that make up the nucleus of an atom, combine together to make a larger nucleus, often leading to the creation of other elements. The result of this process is a lot of energy released, as the final nucleus has less mass than the sum of the nuclei that combine. The difference in mass converted to energy is given by the equation energy is equal to the rest mass of the particles times the speed of light squared. This energy stabilizes the immense gravitational pull the star generates, and thus the star is constantly using hydrogen as fuel to prevent gravitational collapse all along its life.
Galaxy formation. A galaxy is a collection of stars, dust, gas, and dark matter held by gravity. We don't yet have a defined model of how galaxy forms. The first theory was as early as 1934 that proposed galaxy to have formed out of primordial gas whose condensation process could be followed by applying viscous hydrodynamic equations. A few years after that proposal, and he discovers about the universe. Then Nishiyama, working on his proposal of an initiality hot and dense initial phase of the universe, hot Big Bang, leading to primordial nucleosynthesis. His idea was that the gravitational fields of pre-existing galaxies could produce density concentrations in intergalactic gas resulting in the formation of new galaxies due to gravitational instability. Later, in 1965, the situation changed with the discovery of CMB, created two new different scenarios from Joseph Sick and James Peebles that was bottom up, where the larger galaxies are hierarchically assembled for a small system, and the top-down scenario, in which smaller galaxies are formed of fragmentation larger units. In the 1970s, the idea that galaxies emerged out of rotation of the primordial density field became more accepted after the works of Farnsworth, Harrison, and Jacob Sedlovich. Later, with the modern technology, opens a world of possibilities, with the cosmological simulation is a major avenue of research in the field nowadays. Although general scenarios having established many fundamental problems remains open, but it can be resumed as two main theories.
In the formation of galaxies, we can mark two main theories. The first one says that as the nebula collapsed, forming a handful of stars, the spin that the cloud carries was the one that determines what type of galaxy it became. Starting with a significant spin as the cloud collapsed, the spin got even faster by the principle of the angular momentum.
U is L equals m times v times r for each mass. As we pull the cord, the radius r decreases as the masses now move on a circle of smaller radius. Since the value of mass m stays the same, how can L remain constant with r decreasing? V has to increase.
Then, as the spin increased, the material was flattened by the spin axis, creating then the spiral galaxies. On the other hand, if the spin was not present, the elliptical galaxies were formed, making a rounder formation. The second and most accepted theory is that elliptical galaxies were formed from collisions of spiral galaxies. According to this theory, most of the early stages of the universe was covered with spiral galaxies, but over time and gravitational forces, the spiral galaxies merged to form elliptical galaxies. These kind of merges occur very often. This is because the universe is full of galaxies. For example, the Milky Way and the nearest galaxy, Andromeda, they are just separated by 25 times the size of the galaxy themselves. The merge can take from some 100 million to a few billion years to complete. This can derive in the formation of new stars by the melt of the dust and gas from both galaxies, or even the creation of black holes. Even after the merge of two galaxies, the collision between individual stars is very rare, because the distance between them is enormous, but the stars can suffer changes in the orbit.
Despite knowing most of the internal processes that give life to stars, many of their origins remain a mystery to us. We are yet to unveil them and get a bigger picture of our universe. Galaxies, on the other hand, represent an even darker mystery. Their theories undergo many modifications as we gather more information, but at the same time, even more complex problems arise, such as dark matter, black holes, and how they affect the structure of our universe. The possibilities are endless, and from our perspective, there is no end to this rabbit hole. With the help of technology and imagination, we will be able to know the deepest secrets of our universe. This is it for this video. We hope it caught your attention, and now you know more about how stars and galaxies were made. We also hope that this video inspires you to know more about our universe and the wonders it has to offer. Thanks for watching.